Every late summer, the Danish landscape just kind of explodes with these massive, towering yellow flowers.
Yeah, it really does.
I mean, it looks beautiful to a casual observer, but to ecologists, it looks like an active invasion. So today's deep dive is focusing on exactly that. We're following the field research of Kesser and Steen. They're two students from a nature and innovation class.
Right, and they've been rigorously documenting the differences between the native and invasive goldenrods because they actually want to learn how to recognize them out in the wild.
Exactly.
And they're doing this because there's just so much public anxiety about invasive species right now. Like, people constantly stop them in the field, pointing at these giant blooms and demanding to know what they are.
Oh, I bet.
Yeah. So our mission today is to give you the exact same botanical toolkit that Kesser and Steen developed. We're going to cut through all that neighborhood panic and just stick purely to the biology.
Right, so let's establish the baseline using their field notes. The native plant is the common goldenrod, or Solidago virgaurea, I think?
Yes. Nailed it.
Great. So it's on the shorter side, maybe 25 to 80 centimeters tall, kind of hanging out in dry, lightly shaded areas like forest edges. And it's got these very loose, relaxed clusters of yellow flowers. It basically acts like a polite local, just taking up the resources it actually needs.
Exactly. It coexists.
Yeah.
But the two North American imports that are causing all the trouble, the giant Canadian goldenrods, they operate completely differently.
I'm guessing they are not polite locals.
Not at all. They don't just coexist, they conquer. Honestly, instead of polite neighbors, they act more like sprawling corporate monopolies.
Oh, wow.
Yeah, they aggressively form these super dense clumps by spreading through underground rhizome networks.
Right, so that's the real mechanism of the invasion. Those rhizomes create this massive underground grid that just hoards all the soil nutrients.
Precisely.
And then it physically chokes out the native root systems. I mean, that explains why they form such impenetrable clusters above ground. They tower up to 2 meters with hundreds of these densely packed flowers.
You hit the nail on the head. It's a highly effective biological strategy for just taking over new territory. But the immediate challenge for Kesser, Steen, and really anyone walking the trails is that the giant and the Canadian varieties look practically identical to a casual observer.
Right. Looking at the students' research, though, the dead giveaway seems to be the stems.
Yep.
So the giant goldenrod, the one that hits that 2-meter mark, it has a completely smooth stem, usually with a waxy bluish tint.
Yeah, bluish tint.
But the Canadian goldenrod, which maxes out a bit shorter at 1.5 meters, that one features a plush, densely short-haired upper stem. So wait, do I really have to actively pet the weeds to ID them? What if the stems are ambiguous?
Well, stem texture is a crucial adaptation, but you're right. Stems can totally be ambiguous. I mean, think about a plant that's young or maybe damaged by animals or just heavily weathered by a late summer storm.
So if I'm out walking the dog and the stem is completely weathered, am I just stuck?
Not at all. You just have to move to the definitive botanical test, which is flipping the leaf.
Flipping the leaf?
Yeah. Giant goldenrod leaves only have hairs right along the central ribs or the veins. The rest of the underside is totally smooth. The Canadian goldenrod, however, is fuzzy across the entire underside of the leaf.
Oh, wow. So I literally have to flip the foliage over and check for a fuzzy underbelly. I mean, that requires some serious dedication just to identify a weed.
It does, yeah, but it's the most reliable biological marker. And, if you really don't want to get your hands dirty, their survival strategies offer another clue, and that's through their habitat.
Oh, right, because they prefer different environments.
Exactly. Giant goldenrod has evolved a much higher tolerance for wet environments. So if you find a towering cluster dominating the banks of a lake, a watercourse, or a swamp, the odds are heavily in favor of it being the giant variety.
And the Canadian one?
The Canadian goldenrod strongly prefers drier soil.
That actually brings up the practical reality of why these students are researching this so meticulously in the first place. The Danish Nature Agency admits these plants spread so effectively through those rhizome networks that a national eradication is completely off the table.
Yes, the underground grids are simply too established now. They can really only be managed locally.
Which is why public identification is so critical.
Exactly. When you know whether to check for a waxy stem or a fuzzy leaf, you can actually accurately report these imports on platforms like arter.dek. That data is exactly what ecologists use to map the front lines and deploy those targeted local control efforts.
So basically, you now have the exact botanical checklist to confidently ID these plants in the wild, just like Kesser and Steen.
You do. And honestly, it really forces you to reevaluate the scale of human impact.
Mm,
I mean, we imported these plants from North America purely because they looked pretty in a garden setting.
right. Just a simple desire for a nice splash of late summer yellow.
And yet, that single aesthetic choice allowed a plant to quietly hop a garden fence, deploy an aggressive underground network, and permanently rewrite an entire country's ecosystem.
It's wild to think about.
It really is. The next time you see a beautiful exotic flower at the garden center, you really have to wonder what happens when it inevitably jumps the fence.